Hello guys, in today's video we're going to talk about the repair to Panasonic 48-inch. The model number is TX48X60B. The serial number is right here, yeah. And there's a picture of the chassis to the back of the TV, a typical Panasonic setup. The default was the backlight. One, the LED light string was open circuit, and one error flash in the front. The TV shuts down. It goes into backlight. There are some voltages present on T-con board, and then after a second just shuts down with the when one flash error. Here's what the power board looked like, the back of the TV. Just closer here, okay. Okay. That's the underside of the board. That's the top side of the board here. Okay, typical Panasonic board. Nice components. Quality stuff here. This part of the board here is it's a backlight switching circuit here. As you can see, there's two MOSFETs, source, drain, and gates. Switched on by the wee tiny IC here. The supply voltage goes across the transformer here, which is actually switched from the drain as well, and that's rectified by two Schottky diode, and then goes over to two big electrolytic smoother capacitors, and that voltage is routed to the other side of the board, the corner side, which is the LED plus output. And from there we have 6 return circuits. Okay. 1, 2, 3, 4, 5, 6, 7 actually, because one of them is not used by the board. This panel consists of 6 LED strings, which are separated into 2 blocks, like left and right strips. Okay, to the board, but overall 6. Okay, so this is controlled. Sorry. Here. I'm going to do the zoom up here. This is actually dimming controller IC, okay, which is sending the PWM modulation switch, pulse width modulation signal to the base of each of those bipolar transistors. With 6 of them, they are dimming bipolar transistors, okay, and then. And what happens is then the return voltage coming from each of the LED light string goes to the emitter of each of those transistors, and then goes out by a collector to the set of tiny resistors, and then this goes to the ground. Okay. Each of those transistors is modulated from the base by the chip, which in turn gets signals from the main board, the microprocessor. So whenever if you go to the user's menu and control the backlight intensity, the microprocessor, the main board, sends signals to that dimming controller IC, which in turn modulates, the backlight PWM. It's called local dimming. Okay, so what we can do here, and the purpose of this video is just to do the wee mod to the backlight. So the overall backlight, current is just less. It's lower, and the backlight just it's a bit lower, and then it makes the LEDs more reliable. It's like a fooling, circuit. In other words, what happens is just we can zoom up here, and from the actually collector of each of those transistors, signal goes to the set of resistors. The voltage goes to the set of resistors and then goes to ground. Each of those resistors is 2.4 ohms, and they're connected together. This is wee island here, so this goes from there to the wee sort of island, and then another resistor, and then goes to ground. So what it is there's the 6 resistors here, okay, and the overall resistance is very low because there's so many of them. And if the resistance is low and goes to the ground, what means that will create a higher voltage across the LED light strings, and the LED lights fail too soon, prematurely. However, if you just if you increase this resistance by deleting those resistors, if you remove some of those, you will increase the overall resistance here in that circuit, and that in turns creates the higher voltage across them, which in turns reduces the overall voltage across all LED light strings. Um, you know, so what I did here was 6 resistors here, okay. The overall resistance across all of those to ground was over 1 ohm. So if I reduce 2 of them, I will decrease or reduce the backlight intensity by 1/3, because there's 3 rows. Okay, it's 1, 2, 3. So I deleted 2 of them. So I reduced the backlight current by 1/3 of total, and that I measured a red resistance across this here, and then showed there's 2.5 ohm as opposed to 1.5 ohm. Okay, and that makes a huge difference to the backlight current. Although it's not constant DC circuit, as I said before, it's not DC. It's modulated by PWM, but still makes a big difference if you just reduce them. If you just remove those resistors, because the resistance here will be like twice as much as the original. So say for example it will be, for example, 2.5 ohms as opposed to 1.8 ohms, as I said before. So that makes like say, I don't know, 50 milliamps or less of current flowing through LEDs. Okay, so that's pretty similar to that circuit is pretty similar to all average circuits like I'm using this LG or Samsung or Vestel TVs as well. Those circuits are all similar. You can safely do them. I tested that it's safe today. It's not going to do any damage to the TV. So you can safely do that. If you know really what you're doing, you can modify the backlight circuit. Although the picture will be slightly darker, the backlight will be less intense. The customer not going to notice any difference. You can set up the backlight to maximum. As I said before, even if you just replace all the backlights in this circuit, or if you just replace one LED, it doesn't make a difference. It's still going to do much better for the circuit. So it will just make it more reliable, and the backlights will last longer for you. If you have any questions, leave any comments you might have, and then as I say, this video is a continuation to the previous video I made a couple of months ago, in which I explained how the backlight works. This is actually how to modify the backlight to make it more durable and reliable. If you have any questions, please leave comments, or you can subscribe to the channel. Thanks for watching. All the best. Thank you. Bye bye.